Hello PLP Geometry, welcome to lesson 3 in unit 6. So remember, we're doing unit 6 here, and we are covering circles. And this is the third lesson, and we are going to talk about area of a sector. So last lesson we talked about arc length and arc measure, so now we're going to talk about the area of a sector. So what in the world is a sector in a circle? So sector of a circle. So a sector of a circle is a region bounded by two radii. Bounded by two radii and the intercepted arc. Okay, so this is intercepted arc, and in parentheses I'm going to put your piece of pie. Piece of pie. So when you think of a sector, right? If you think of a circle as a pie, we're going to call this circle Q. So here are my two radii, one going like this, one going like this. So let's draw Q to M as one of the radii, and then Q to N as the other radii, right? So this piece here, bounded by the two radii and the arc, MN, this is your sector, right in here. That's your sector. Now, we want to find the area of that sector. Area of a sector. So just like arc length was a fraction of the area's circumference, the area of a sector is a fraction of the circle's area. Fraction of the circle's area. Okay. And again, there are two ways to think about this. One is proportionally, the other one is just using a formula. So the first way we'll talk about is the proportion way. So again, if you think of the area of the sector divided by the circle's area, area of a sector divided by the circle's area, that should be equal to the arc measure. So we're still doing that arc measure. That's the degrees out of 360, right? And again, this is the proportion way. I'll put the word proportion right here. Proportion. So again, if we use symbols, so we're going to let capital A be for the area sector, out of the circle's area, which is pi r squared, and that's going to equal the arc measure, which is that n value over 360. And again, this is how I'm going to present it most of the time in the practice problems. Now, there is a second formula, or, and again, it's just kind of this formula solved for A, so it's going to be equal to A equals, so it's the fraction of the circle, so n over 360 times the area pi r squared. And you can use this one as well. So either formula will work. Okay, so let's do two examples to get you set with these area of a sector problems. Okay. So the first example, we'll call it example 1. So we will find the area, of sector FGH. Okay, so in this picture, here is your circle. So the center is going to be G, and my two radii go out to F and go out to H. So they're going to tell you that FG equals 10. So FG is your radius, so that's going to be 10. So this is your radius, right? They're also going to tell you that the measure of the central angle, FGH, is equal to, in this case, 34 degrees. So that goes here. 34, not 35. Sorry about that. And again, that's going to be the measure of the arc. So that's also going to go out here at 34 degrees. So that is equal to the measure of arc FH. Okay, and we are looking for this area all in here. So we're going to use that proportion formula. So it is going to be the area of the sector, which is what I'm trying to find, over the area of the circle. Pi times 10 squared equals the angle measure, 34, over 360. And again, we're going to cross multiply. So again, when you cross multiply, the A gets multiplied with the 360. So that's 360 times A. The pi, 10 squared times 34 gets multiplied. I'm not going to type in the pi yet, just to kind of keep things nice and pretty before the decimals. So if you do 10 squared times 34, you get 3,400, and the pi just comes with it. And now to get A by itself, now we divide by 360. The 360 cancel, A equals, and again, if we take a look at this, I got, and I typed in the pi this time, right? 3,400 pi divided by 360, I get 29.670. They want it to the nearest hundredth, so that's the 7. The 0 does not change the 7, so that's 29.67. And this is area, so that'd be units squared. And that's how you find the area of that sector. Okay, and then let's do another example. So this is example 2. So example 2 here, now we want to find the length. Find the length of IJ, segment IJ. Here's the picture. So I is the center. We have I to J here, and we have I to K here, and this is my arc. So they want us to find IJ. That's right here. IJ is the radius. So this problem says we are looking for the radius. So keep that in mind, right? Now they're going to give you two things. They're going to give you the measure of the central angle, JIK, and in this case, JIK has 144 degrees. 144 degrees. That goes right here. Remember, that's also the measure of the arc. So the measure of arc KJ. And now we also are going to be given the area of the sector. In this case, the area of the sector is 10 pi. And again, I love it when they give you the pi because it's going to let the pi's cancel. So keep that in mind. So that is this area here. And again, we want to find the radius. So we're going to stick to our formula. So we know the area. The area is 10 pi. That's the area of the sector. Over the area of the circle, pi r squared. We don't know r, so leave r alone. Equals, we know the measure of the arc is 144 out of 360. Okay, so first off, the pi's are going to cancel. And now I'm going to cross multiply. So when the pi's cancel, life is a little bit better. R squared gets multiplied with 144 to be 144 r squared. 10 gets multiplied with 360 to become 3,600. We're going to divide both sides by 144 to get the r squared by itself. So we get r squared equals, when you do that, you get 25. And then to get rid of this squared, we take the square root. And the square root of 25 is a nice 5. And your radius would be 5 units long. And there we go. Perfect. Okay, so again, good luck working with this area of a sector equation, and we'll see you in class.